Yeah. 1 second. You never know. When you watch recording and understand that it already started. Okay, we definitely started now. Hello, everyone. I just
Hi.
returned. Yeah, hi,
Nick,
Andrey. Hi,
Andrey.
Kirk. Yeah, I just returned from Japan. I want to go back soon again. I know Kirk just visited Japan as well. It was great trip as well, right? You
Awesome.
enjoyed it? Yeah, you
Yeah,
enjoyed.
great culture. Um, the mall, the multi-story mall that's actually part of the underground subway system, kind of cool.
You're talking about Tokyo, right? I was only in Osaka or Osaka, how to
Oh,
pronounce.
Osaka. Yeah, I
Yeah.
was in Tokyo,
Osaka is
Kyoto, and
wrong.
Osaka.
Osaka is wrong. I talked to many taxi drivers, and none of them say Osaka. This pronunciation is from the US.
America, just like Moscow. Nobody in Russia says Moscow, do they?
Right.
Right,
Yeah.
Moskva.
So yeah, exactly. So yeah, I also noticed more like city under city basically. And yeah, that's great. But the most I liked was the food.
Oh, yes, yeah.
Expected actually. Yeah. Met expectations. Anyway, Postgres and AI and what else? Let's
And
talk.
compression talk.
Yeah. So we have a bunch of things to discuss and maybe do today. Where to start? And let's start somewhere, and I will go and drop some links in some places so people could join. Where to start?
I think with Vandra's comments on AI.
Right. Tomasz Vondra wrote a blog post about the use of AI for Postgres project, contributing to Postgres. So in general, it looked to me as opposing the use of AI and discussing a lot of potential harm, right? Or
It's like not opposing, but like
Warning,
cautious use. Yeah.
warning, yeah.
caution.
Okay. So what are
And
your thoughts
if
about
I
it?
summarize the key takeaway for me from the article, it was, hey, a healthy community is either stable or growing with people coming in. There's always more new people than old people. This is the pattern, yada, yada, yada. And his fear is that as AI is lowering some barriers for people to get in, that you're going to overwhelm the people you need to stick around, which are the more tenured people and some of that. And some of the extra noise, and people know this, the hallucinations, things like that, some bad code, if you're not truly reviewing it yourself and just sending in whatever it writes, don't do that. Anyways, but there's some warnings there because it's not just about code, it's about what it does to the community. And so, but I think he's open to it. His warning, and it's a caution to me, is that it could damage the community. And he's not wrong. So,
Mhm.
how we adapt AI, and if we focus on making it so that AI is primarily used to take the heavy weights off of the most senior people's shoulders, I think that'll be far more welcome, but we kind of have to get there. Anyways, that was my take on it.
Andrei, what do
Uh,
you think? What do you think?
I think, I mean, we observe a lot of contributions that are marginally useful, but like like renaming variables and fixing spaces and indentation. It's not really entering communities. It's just create an impression of entering community. But what I want to emphasize, like if we are talking about AI, which exactly AI are we talking? I mean mostly in in time. Is this AI that is today? Is it that AI was half a year ago? Is it completely different AI?
Oh yes.
Or is it
A month
AI that
ago.
is taken
Uh,
to extreme? Because AI taken to extreme will take care of Postgres instead of committers. Probably. Why not? If it's absolute mind that knows everything and fixes every bug and foresee future and all that stuff. If we are talking about AI that is there today, it is misleading, very, very misleading. Like if you don't know how things works, it can lead you to like a very wrong way. And many newcomers might decide that it's easy to enter Postgres core development as it's easy today to enter just usual programming, and they can lead wrong way and be scared of stuff that we are doing.
Well, if you take the latest models right now, I found it quite useful, at least for explaining what this patch is about and how to apply it and run it properly quicker, so barrier of entry
Yes,
is lower.
but if you give them a challenging task that is
Like
actually
you
community,
did with pglz compression.
like we all did here,
Right.
Right.
removing pages, like merging pages in between.
This is the absolute extreme task, I would say.
But it seems easy. It seems like why I can
Right.
do it.
But we did it, by the way, we did it on weaker model, and it was already 2 months ago, and it was, I think we didn't use Opus even not
If we'll take fresh Opus 4.6, it will say happy to say, oh, let's try.
I waited
it
for
looks
this,
like
it will say.
Yeah. Finally, you came to me with this problem. I've got you.
yeah.
Like you maybe you all saw it, like, oh, now things are getting interesting, right? This is one of the favorite
Yes.
phrases.
And it will
Like,
face the same dead end that we did. And it's not dead, completely dead. It's just difficult, and it will be difficult for modern model too. But a few months ago, compression was difficult for Sonnet 4.5.
Right.
But this month, it can refactor the patch actually, not destroying everything.
Yeah, also big change over the last couple of months, maybe since the end of December. You probably all saw this original Twitter post from Andrey about like Alien and so on, which got like 30 plus million views. So 15 plus maybe. The big fact is that it now can so AI tools can run longer, right, and iterate autonomously. And this is very important because now my workflow completely changed. I spend a lot of time creating a spec, like very detailed spec, like specification,
Yeah.
right? So all the details like about goals, about tools, approaches, and then step by step implementation plan. And this spec is reviewed by me and by other AI models, many of them. Like we usually have at least 5 iterations. A lot of things are changing before we start actual work. And we keep it in Git and so on. You will see probably this in this pglz example. And then I just go for many hours, go to sleep usually.
And let the AI agents work on it, or wait, right? Good.
Yeah, Ralph loop, yeah.
But
Or
kudos.
OpenClaw or any, yeah.
What you just explained, though, was the key thing most people don't comprehend. It's not a prompt when we're using it to program. It's a specification guidelines.
Yeah.
So you need to specify all of those things. And the reason you're doing it is the number of failed attempts to get where you're going when you don't do it that way. And I love, you just said, listen, I use iteration on the specs before I give it to get the work done. And I can have the AIs review the specs with me. When you start treating it as something that's that important, you start getting great results, in my opinion.
Yeah, so you spend a lot of time designing, and this is where you need to understand various like trade-offs, approaches, compare them, and basically it's engineering, right? It's not code writing, but it's engineering. And at this step, you probably need some research to be done.
Yep.
Like this, I usually like what are existing attempts to solve this problem, right? So it's great, like, and without to do it manually, it's a lot of work. But when you do it with these AI tools, they bring all the info with links, and then if something is bullshitting you, like hallucinating, it will be caught at the stage of testing this spec, right? It reminds me. So I was taught by professors who developed IT systems for space in 60s and 70s.
Wow.
When, yeah, there was a computer called BESM 6, and it supported Soviet space systems. And they taught us that there are many stages of testing, and before we start writing code, you need to create proper specification and then spend a lot of effort by multiple people to test the spec from different angles. Because back then, computer was super expensive and hard to reach, right? Because you need, you have like small chance for your program which you wrote without computer to just work. And I remember when they taught us, I was like annoyed because all education happened on whiteboard, no computers. It was super strange. Like you guys are dinosaurs, I thought. But now I just think this is exactly which is needed. You know, this was called waterfall model, right? And it was wiped out by various extreme programming techniques. Do you remember XP and
Oh,
pair programming and short
Rational.
iterations? Yeah. And then like very fast cycles, like let's have
rapid
like
application development.
yeah, and then
Yeah.
agile and Scrum and all everything. And now I'm thinking, okay, we have a loop here. We need proper waterfall model, right? So we need to test specification very thoroughly to prepare before we write code, right? And this is I'm very grateful right now for that whiteboard uh, education, you know,
That's funny
from
because
dinosaurs. I'm very grateful. Unfortunately, they all died already. Yeah, but
you
they're great people who pioneered in 70s, you know, like before internet, and now I'm just using what I learned from them. It's crazy.
everything old is new again. And
Yeah.
back in the day, if you remember what MVS was, that was the multiple virtual systems. So you bought one big IBM machine and it was too big. So you could actually create virtual
Yeah.
machines on the hardware, the mainframe, and have them each running different because every machine only ran one application, much more like Docker, right? The core was provided and then it ran inside this. But we're exactly back to that place again.
Oh, I remember the class where was only two computers. The teacher had computer and one more computer for all students, and
Yes.
all they had is just a thin terminal, like it's just
Right.
display and keyboard. That's it. And now we have a bunch of couple of three,
Cloud-based
four
computers,
VMs where we have AI, multiple bots, and all other and thin
web
interface
browsers.
in form of Slack usually or Telegram.
I'll blow your mind one step further. You know how an HTML page takes all your input and posts it to the server? That's
Okay.
exactly how a mainframe dumb terminal worked. You drew the screen,
Yeah.
they typed on the fields locally. None of that went to the mainframe because it couldn't process keystrokes. It all stayed on the terminal. And when you hit the XMIT or the submit button on the keyboard, that did a submit just like the web page does. And it only sends back all of your fields tagged by numbers and their values and the name of the page of the program you were running. And that read it in and then processed it. And in fact, that's the entire API behind SAP. The SAP software is literally their SAPI SAP API. You have to tell it what program page you're going to send the data for, and then that's how it knows to run it. So I got
Yeah,
lucky. I grew up on paper terminals. So I
yeah,
grew up
it's
typing and learning on paper terminals. We wrote out our code by hand. And if you ever ran Edlin on the old DOS, okay, we had an editor that was just like that, just a little more powerful, editing
so
one line at a time.
yeah. So it's interesting. Like definitely, you also see some similarities here. But maybe let's go back to Thomas article and Andrei. Anything to add? Like No, like
I think Tomasz and others understand that it's inevitable. Like we are with the AI, AI is with us, and this is just a new way to work and develop a way to produce same level of quality in presence of these tools. So we definitely will see much higher velocity, much faster development. And what we need is like do not lose quality. Few weeks ago, we woke up late and we were late to the school. And when my wife opened, slid up lock screen, she heard wake up call alarm ringing. This was a bug in Apple's operating system, and this AI generated bugs everywhere now.
oh yeah,
I
status
know.
pages are all big. Yeah,
Yes, and you know, you see, you know
yeah.
by nature of bugs that it's not human
Yes,
made bug.
yes,
I hope
yeah,
AI is not running airplanes firmware, at least
yeah,
now.
yeah,
Ah,
yeah.
so
Yeah, if you
so
check, for
something.
example, status GitHub.com, it's terrible. It
eh,
used to be quite green, but now it's terrible.
So something I want to mention though, because we can pick on the AI a little bit for not being able to solve the problem of the bloat in the indexes. But I want to point out we spent most of that session a little bit in discovery mode and having it build code that actually worked that told us how bloated the index got. And we created that. It's not like we spent 60 hours on this problem. Okay. It's not like we spent 60 hours or even 20 hours giving it the definition of what you wanted it to do. And so I want to defend the AI a little bit because sometimes we're moving so fast, right? Even if we have a metal mind who can, outstrip us with
Silicon Mind.
performance. Yes,
Silicon Mind.
silicon mind. The challenge becomes, did we give it a great specification? And I think that's the point that Nick was making. If we go back to what we did and start with that as a starting point, and then have it implement a few things and maybe a completely locked version of compressing pages, but let it get build it back up from the ground up maybe, and maybe we could have much better progress, especially now that even the models are newer. That's my take. Shoot me down.
Yeah. No, no. And also, so I think you need just to have a lot of effort in the beginning and also in the end, at the end, when you need to test and review what like the result.
Last 5% of work,
Yeah.
which
Yeah.
take
Long tail of work. Yeah. Yeah, and there I have my approach where I use multiple agents, and it's working great actually since the beginning of January. I use it even for documentation pull requests. So yeah. Anyway, one more thing I wanted to add. I hate mailing list and patches. You probably know. Yeah. And with AI, it's so much easier, right? Just why? Yeah, I find it super easy to to understand what's happening in very long discussion and summarize it and understand like all patches version provide me summary and see like what comments were, right? Because comments in this approach are like, okay, in that patch version on that line there is something like you need to open the file, like oh, like it's a lot of legwork. Now it's if it's done by AI and you trust it, you need to trust it. So yeah.
But
you can
even
trust in summarizing. Yes,
yeah,
further go on.
no, but even what you just said, it is helpful when it comes because we kind of get into the point where we understand how to do the get and the push, and all of this stuff to get things up there, but they're not using that. So now they want you to create patch files. Then the patch files have to be named properly, right? So now so all of this extra stuff, and this is what Vondra skips over. Okay, that's all a barrier to entry to everyone from the outside. To the people who are on the inside, it's the secret handshake that tells them you already know a little bit about what you're doing. The AI can actually package up any patch you want and kind of get that stuff right and help write the email for you. And like you just said, include the references. Like I'm impressed by how many times I see bracketed numbers in the Postgres hackers group. And then down underneath that, they actually go through and put the links in and just boom, boom, boom. So you can actually quickly get, that's awesome. Okay. That's great feedback. And my patches aren't up to that level. I'm just saying.
I think we could create a skill for Cloud Code or OpenClaw or Codex. It's just a bunch of prompts which would explain how things usually are done in Postgres mailing lists, how to properly format and name patches, versions of them, and how to format emails properly and so on.
And that segues into
it's not difficult.
Google Summer of Code.
Yeah,
because
and we could just
all of these
offer
people
it.
are going to have to do this.
So that's the second thing I wanted to touch. Google Summer of Code. We obviously are in, right? So like participating a little bit with ideas we discussed on previous calls. It's still not fully clear to me what's the policy for Postgres project, because I saw only the document from Google which says you need to define the policy, but what's the policy?
Oh, the AI policy.
Yeah. It's not clear.
I think every group gets to choose their own AI policy. And so I think we just got to reach out to Pavlo and figure out what he's expecting.
Yeah, good idea. Yeah. I think I should be there, but with some how like the very popular word right now, guardrails.
Yeah, I think we can just like come up with some ideas what can be in our policy. I have in mind like simple policy, like read what you send.
Test, read, review yourself.
At least read every word. That would be enough, I think.
Well, read
should be
read and understand, because just read, it's like
we can rephrase like own your words. Like you said it, it's you. If
own what you do. This is the key, right? But what does it mean, own? Yeah. And by the way,
as if every word was said by you. Every line was written by you. If you break stuff, you are responsible for fixing the stuff.
Yeah.
If you're like break, I know, community relationships, it's your relationships, not AI. AI
or
is not
mentors,
excuse.
not mentors.
Not the mentors. Yeah. Right.
Yeah. By the way, I use the term vibe hacking in YouTube and everywhere. I'm going to drop it and propose a new term, agentic hacking.
There you go. And here's the deal. Vibe coding and vibe hacking to me is seat of your pants. Okay. And the process you described a few minutes ago is anything but seat of your pants. It's not just vibing it. You're literally, if you're building a spec,
engineering,
yeah, agentic, So I don't mind agentic coding, agentic engineering, whatever but yeah, I'm not a big fan of the vibe coding, vibe hacking. So
agentic
I'm a big
hacking.
fan of hacking. So let's
whatever hacking, right?
Yes.
Yeah.
It's
okay.
About creativity.
Let's do some hacking then.
I mean, tools can be just anything. You can use anything as a tool, but hacking is important part for me.
Good. Let's do some hacking or discussing some hacking in particular. So there is pglz compression, which I always find quite weak, and in many places where supported we switch to LZ4 because it's quite usually low CPU but better gain in terms of compression ratio. But Andrey brought the topic pglz can be improved, and there is long thread in PGSQL hackers mailing list. I'm going to find a link and post it to chat and then to comments. But it was considered like some bulky patch, which should be split to multiple patches or something. So anyway, I applied this approach with writing a spec and then going to sleep. But I never properly review what happened in the end. So we should probably think what to
we
do.
should
I
review.
tried to start to look into it, and there is a lot of stuff, and I just do not understand where to start.
Let's make sure we're on the same page, though. So it sounded like you got feedback from the hackers group on the original pass for trying to add this compression, and that was where Andrey had written the original set of code, right? Andrey?
No, it was intern in my team.
Okay.
Who wrote it? He is a champion in ICPC, like sport programming.
Computer programming.
At some point, he produced a huge patch, which is just difficult for me to refactor. It is correct. It is producing correct GLZ compressed stuff faster, like 40% faster, and there are a mixture of optimizations, and I just cannot tear them apart. And hackers told me that like we need to verify them, and we need to verify them one by one, not a mixture of optimizations.
And there were 5 basic changes he made. Four or 5, right?
But I think AI suggested something new on top of what was done.
Yeah. Well, yeah, let's maybe... So I'm going to share right now the link to the thread, PGSQL hackers.
Good. And I was just trying to cover the history to catch people up who are outside the conversation. So this started, it got submitted to the hackers. The hackers pushed back going, how do you expect us to review it? It hurt Andrey's brain. And so now it came back and Nick picked it up and says, well, let's see if I can get my agents to divide and conquer on this thing. And so he did his agentic stuff and shot it off. And sure enough, they started separating it out and got it to the point of running analysis and speed testing. And I think they agreed to pull one of them, but they've now turned it into a series of individual patches that can be applied separately. And that's where we're at in this story. Sorry. Catch everyone up.
Yeah, so I posted links to chat, and in this case, I created whole GitHub repository, and I used, I think, 4 agents working together, 1 manager, 3 engineers or something like this, and they just had issues, pull requests, it's a lot of things happening, and we have multiple cycles, and they decided to split the patch, tested, found like the gain not so huge at grander scale if you test whole Postgres, not just some function. And then I think I went to Japan and got lost in this.
Yeah. You had it, what's the term in the AI? You had it clear your cache or whatever. So you come back and it's like, where were we at?
Right. So, but Andrey, you looked at it, right?
Yeah, I was starting to look at it, but which chat did you post the link to?
Oh, it's in the vibe coding, the vibe hacking on Telegram. He posted the video, that's the video. Where did you post the one with the link to the source?
I will post it in Telegram as well right now. Yeah, cool. I posted it at chat on YouTube.
Okay.
Oh.
But I'm going to use our Telegram group.
Yeah. I'm
here.
Yeah, it's original thread and
here, yeah.
Yeah. So, will you show what's there, or let me do it?
Yeah, if you can, please do.
Yeah, I think I can do it. Do you see my desktop?
Yes.
Yep. We see bench, patches, scripts, and tests.
Yeah, it's so this repository is a whole product of their work, nothing accepted, right?
Right.
Yeah, just preparation.
Yeah, and there are several branches.
Right. And pull requests, some of them already merged, some of them are not merged, and issues are open still.
Okay, maybe we can see something like network of commits. I do not remember how to like find what was last thing that was done.
Yeah, let's check the spec, because I track progress in spec. Spec is main source of truth always for me, not only goal setting and steps, but also tracking progress. It's in the end that you should see the list with checkboxes.
Oh, it's lengthy.
I hope so. Should be. Yeah. Right. So if you scroll up, I think 2 sprints were done already. Yeah. So.
Oh, we didn't even talk about single instruction, multiple data optimization. So something.
It's next already. Yeah. But
Far,
scroll up. So they had 2 sprints, basically, like you can think about like weeks of work. One sprint and second sprint, and they should be done.
Wait, what? For sprint 1. So they implemented Turing patch into 5 patches.
Right.
And benchmarked it.
Right. Also, if you go to issues later, you will see already proposal for email to hackers, and we should find patch links to patches there. So, for example, 23, issue 23. Or issue 19 also, one of them.
I'm sorry, were your agents using the issues to post the issues to, Nick?
Yeah, so I didn't post anything. It's all those agents. You cannot distinguish them, unfortunately, here.
From you.
Because, yeah, they look like me.
Sprint 2 was before Sprint 3, so since 23 was probably final.
Well, it's not final. We had more plans there. They had more plans there. But yeah, there are several patches here already, right? And yeah. So they created issues. So one of them is manager. Manager thought about how to split work to 2 issues, created issues, then multiple agents worked on them, performed cross review of pull requests before merging. They merged. So and they tested. They had ability to provision virtual machines in cloud for testing. I remember up to 16 of the CPUs I allowed. Yeah, something like this. Oh yeah, you see Hetzner, AMD Epic. Oh, 4 vCPU, so small machine.
I am curious about the abbreviation of the compression down to LZ, and they just dropped the W. Welch's contribution was kind of key, but because this is like a real-time streaming version, is that kind of why they're not, or is it just easier to say LZ compression instead of LZW?
Sorry, Kirk. I was reading. I didn't understand you.
So they dropped the W off of LZW compression. Was there a reason for that? It's Limpel, Zev, and Welch.
Welch,
right?
Yes. Welch optimizations were not used in this.
Okay, good. Thank you.
You can actually, I mean, you can open this file, GLZ compress, and there is a link on a scientific paper. So it was all written by, I think, by Jan Wick.
Okay.
When you said about weak compression, I thought that maybe it's Wix compression. It's Googleable.
Okay, cool. You don't have to look it up any further than that. I was just curious. Usually it goes together, and it was missing.
So here is that compression. Probably we can find mention why it's not Welsh. No, it's not. Okay, so this is what I see here. What is immediately visible to me is that it is benchmarking wall compression, and it is generating far less wall. That means that algorithm is changed, and the idea of the patch is acceptable was that we are guaranteeing that it is generating the very same output for the same input.
Whoa! How does that give you any improvements? Oh, we're only looking for algorithmic speed improvements of computation or data handling. We're not looking for improvements in compression.
Yes, we were trying to make things faster, not compressed better. And here, as an output, we have a much better compression ratio.
Amazing.
4 times better compression, but it drops transactions per second very, very deeply. So we are essentially providing another codec that is another point on Pareto frontier. So we have that frontier that is essentially balanced between performance and compression ratio. When we are moving only on one axis, like we are providing better ratio with same performance, or providing same ratio with better performance. It's strictly good. But here we are providing a trade-off. Faster, but we are slower, but better compression ratio. And that's not obviously good. It's difficult to prove.
Andrey, I think you are right. But in this particular case, if you notice, pgbench parameters, it was 60 seconds duration, and due to lower TPS, it was just less bytes, fewer bytes generated, right? I think we should use not time-based pgbench, but number of transaction-based to be able to compare, right? So it's not capital T, but instead capital R or capital. So there is a way to say I want 1 million transactions.
Is this small t and
maybe yeah. So this is what we should use here. This is just wrong approach. In this case, we would see this would be good verification. We should be able to compare all bytes. Just wrong approach to compare time-based.
Right. Yeah,
but maybe
again,
maybe we have the same output. We don't know here, right? This is good note. Do we have AI making notes? Yes, we have. I'm going to feed it after this call and include it to some issue and iterate on it.
That's interesting because it looks like wall is compressible, is easily compressible. And I think another hash function gave actually a chance to GLZ to compress better. But when it is compressing, it is doing work. It is spending CPU cycles, which is dropping transactions per second.
So patched version were more expensive in terms of CPU. Unfortunately, this is not what we want here.
Yes, it generates less I/O, but
again, maybe no. Maybe it generates the same I/O, but slower. That's why in 60 seconds it's less. This is what I'm trying to say.
I understand your point. Yes.
Yeah, it was CPU bound. Maybe that's it. And this is again, this is just one of the versions. we had like more than a dozen of versions. So we are looking at some particular patch tested, right?
Oh, which so there are numbers. I do not understand which
Yeah, I also don't understand
exactly.
which. Maybe let's look at other issues that's not clear here.
Isolated tests.
You see versions, right? Step 1, step 2, these are different pieces of the patch, original patch. But definitely the methodology of benchmarking is wrong here. We need
So it understood that that some step of patch is reducing transaction per second, and probably it fixed it later.
And it decided to remove that step. Like bad step.
Okay, so let's scroll down. You know.
I'm talking to the manager right now. It insists that output should be identical. Yeah, so what I described. Less work, less wall, it says. But definitely we should switch
so it
to...
is proposing 4 patch series.
Right.
That according to its benchmarks gives about 1% of transaction per second.
Not a lot. So
that's not a lot, but that's more than not a lot. That's something that I cannot verify on my laptop. If we have like 10% of performance improvement, we can see it with eyes, and we don't need statistics to observe.
This is noise level difference.
Yes. But 17% of raw pglz throughput is like it makes sense. And we had some benchmark that is inside Postgres, but shows pglz throughput, something about something like that. I think Tomasz proposed something for this in previous iterations when he was working on pglz decompression.
Can you look at also at 19 issue 19? Because there is this cover letter.
That's what I was going to read next.
Okay, great.
So it is proposing something for us to send. Hi hackers, patch series improves pglz compressors. I mean,
so
in this message, it's going to describe the long road that we have passed, that it have passed, and why it just decided to dump one of steps. I think that we can say that just we dumped it and that's it.
Right.
Kirk,
right.
Kirk, you was saying something?
Yeah. So I just, off the back of the envelope, I looked at the number of transactions per second. And what I did was I took the wall that was generated in both those cases, and I divided it by the number of transactions per second. So the bytes of wall divided by transactions per second.
That's smart. This is class 3 level math, right?
Exactly.
I didn't think about this. That's great.
So and it's 30% less with the new pglz. Okay, so technically, yes, it did spend more CPU, like it got fewer transactions, but it actually accomplish far more wall per transaction. So I thought that was interesting. But I was just looking at the crunching of those two numbers. So it's a 30% difference when you divide it out. So if you divide the number of bytes by the transactions per second. But yeah, the correct answer is we don't need to run this for 60 seconds. We need to run it for,
1 million transactions.
Yeah, 1 million or 2 million transactions. And if that's an easy test to get kicked off, that would be nice to do. That will tell us. The challenge is, how do we constrain that level of CPU, right? Because what Andrey said is, you got the Pareto's thing, right? You can have it fast, right, or cheap. Choose two. In this case, we're down we want it correct, and then we would prefer it's faster, right? Or the same speed if it's using less CPU, like same clock speed but less, right? So resource management. So, but okay. Cool. I was looking there. How are we looking? So are we all on the same page? Obviously, we got to rerun some of these tests to see how this looks. What else? Did we look at any of the code to see?
I solved the mystery of W. So yeah,
what was with Welsh?
Abraham Lempel, Jacob Ziv, Terry Welsh. Okay, so Welsh published practical improvement of LZ78 in 1984. And W wasn't dropped. LZ77 and LZ78 are base algorithms. And LZW is specifically the Welsh variant. pglz is based on LZ77, not LZW. So there's no W to drop, it says. Is it so?
Okay. Interesting.
So? Why? Okay. Yeah.
So the other benchmark, those benchmarks, this like AI is supposed to send, seems like different win. Like we see 14% of improvement in a Postgres workload, not an isolated program. Like
right.
long strings are inserted 14% faster. So
this is not noise already. Yeah.
Yeah, we can verify it on a laptop and check that it's it's real.
So a couple things that will need to happen at some point is we have to make sure we can start these initialized in the same way, like after a checkpoint or when the wall's been cleared, because at the end of the day, part of our confirmation should be, hey, we compared the wall that was output, and we either need to say it was correct, meaning it didn't change, or we have to actually prove the decompressibility of the wall. Okay, if we can't force it to match, we can do a byte by byte comparison, then we're going to have to at least make sure that it completely decompresses without error, right? That it can be all properly read back in. What's the correct way to test that?
Roll it into production on million servers and see if it still works. I don't know. I mean, that standard, like one of top codecs, and from time to time they find data corruption there still. So it's a codec that is used to compress all the data in Facebook and most of data in Google. Yet somehow data is not always decompressed.
I suddenly don't feel good.
We can try to check that there are no corruptions right now.
Oh, I remember Broadly also had issues. Broadly is from Google, I guess, right? Oh, yeah. This is Pied Piper level of work. Have you watched Silicon Valley, old TV show? No. Yeah, they worked on compression as well. Interesting.
Yeah, I was working on picture image compression. We were working when I was.
Tom Lane also worked on this. you know?
Yeah, but Tom
PNG.
Tom was
JPEG?
working on real compression that happened to like power internet right now.
Yeah.
I think many images here are PNG, but I was
Or
working in
JPEG.
startup. Yes, Joint Picture Experts Group. We were trying to develop a codec, wavelet-based codec on a startup back in 2004, I think.
Ooh, that's
That
very
was my first software job, I think. Legal
Cool.
software job.
Cool.
Wow. So this can generate. I mean, I know there's some cool tricks you can play, like you can hand code in almost a near infinite, decompression loop, right? So you can create a small zip file that decompresses to like multiple terabytes, and it does it by just kind of repeating this complex pattern, but it's just repetition count, right? To go write 10 terabytes of X on the hard drive.
So interesting. I double checked about LZW once again. It has patent issue first of all, and second, it was much more complex than LZ77. So that's why
Yeah,
it wasn't used here.
if I remember, the core difference was Limpel and Zev combined needed to generate a table of the compression pieces that they compressed into tokens, and then they stored it at the end. And Welch's contribution was, hold it. If we at least write out some of the initial stuff, can't we produce something so that when we're reading it in, we can generate that same table at the same time? And then you no longer had to store the table at the end of the compressed file. But yes, it makes the algorithm a little more complicated. But yeah, I was reading that. I think it was college in 92. So,
So there are 26 commits about data corruption. That's standard. So I would propose to leave algorithm intact, if possible.
okay. I just didn't know if the algorithm was changing based on what we were doing. Meaning, how do we, if the requirement from the hackers was, you guys are going to have to prove that you didn't break any of the encryption, like not encryption, but compression, that what you're getting back out is either the same as what the other code would have generated, or we have to show that, technically that's the only way to make sure that we didn't change something. And I guess, you know what? We could just do that. We don't have to test that in situ, right? We could actually just test that by routing, a shit ton of data through the algorithm, and in both algorithms, right?
Mhm.
Just custom call those algorithms as our proof, and then make sure that over a range of data, that the compressed data on the outside matches each of them.
We cannot, like, the window is 4 kilobytes. We cannot test it on every possible 4 kilobyte input.
Oh yes.
It's
We
just too
can
much.
just download Reddit and use it on Reddit.
No, just have it generate. Just have the system randomly generate, the complexities.
How randomly? This is different question. Algorithm.
Yes, because it's random data is not compressible, and most
right.
of random inputs will not produce any compression at all. So just random enough input is meaningless for compression codec. The idea is that we are making most of inputs larger, but frequent inputs, which are not random, smaller. On average, compression is not negative, but it's useful for realistic inputs. But the idea of compressing the whole Reddit probably is a correct one.
So Andrey, you say we should avoid thinking about changing algorithm right now and just focusing on optimizations.
Yes. I think it's non-committable, or
Yeah,
at least at last commit fast. So we
What-
can take time to prove it's correct
Yeah.
with another algorithm.
Which particular optimizations you think are most promising to explore further?
That don't require changing the algorithm.
All right.
I do not remember a single one of them, actually.
Let's maybe check the spec once again and what ideas Silicon Brain had.
Well,
So
the first one
refactoring,
doesn't do much. Go ahead.
yeah, so I think the difference is from that patch 5 Fibonacci multiplicative hash, which actually allows it to use hash table more efficiently. So it works because because it have less collisions, and there are more cases when you find a match that was missed by previous algorithm.
But this is already a different algorithm.
Yes, but now it's a different algorithm with different compression ratio.
Yeah. So this should be removed. Okay.
And then what about patch 4? A 4-byte comparison versus another byte comparison.
It was the same comparison, just different, different way to use CPU to compare 32 bits.
Okay, instead of doing 2-byte comparison, do 1 4-byte comparison. Okay,
yes.
Cool. Then that passes. The test we're checking. And then backing up, singly list history with predecessor scan unlink. Again, if you find something that you normally wouldn't have found, that's going to change what the output looks like.
I do not understand what is it. Something about lists.
Something about lists. So my understanding of what that is so there is a list of substitutions you can make while you're scanning and compressing. And so if they change this, right, so they use a singly linked history with predecessor scan, unlink. If they use it this way, maybe it used to be a doubly linked list. And they're like, hey, no, just start with a singly linked list, whatever, because not maintaining the double link is whatever benefit. The challenge is if it ends up affecting what you find, then that can completely affect how it continues to compress. But I don't know enough about the patch.
I think like it's about a cache table. What is cache table? It's just like hash table, but it doesn't like when you see like 4 bytes, you want to answer first. Have I ever saw 4 bytes in input stream before?
Okay.
And you have this cache table that says that, okay, you saw these 4 bytes at offset 37, at offset 77, and at offset 1 kilobyte and 37.
Whatever.
Like for example, yes. And then you try to find which is longest sequence for your match, because your match doesn't end with 4 bytes. You try to extend it further and further.
Right.
Maybe you have a longer match than just 4 bytes. And double linked list was there because we needed to evict matches that are beyond our compression window. In pglz, we can emit match only 4 kilobytes back. And matches that happened before, they are not usable, and you need to remove them from cache table to and at Yanwick implementations, at Yanwick's implementation, it was done by double linked list, and Vladimir Leskov, a guy who wrote this, used single linked list with some his ICPC magic. But it should be still the same algorithm, like byte to byte, same algorithm.
byte-to-byte output.
Yes,
Inside
byte.
it can be slightly different, but output must not change.
Yes, yes.
So I wish I knew this requirement in the beginning, right?
I didn't forget it. Sorry.
No problem.
I
just
didn't remember it.
Yeah, I just forwarded you personally, two of you, the revised list of optimization ideas after I said output must not change. So it dropped multiple ideas, including 4-byte memcmp fast reject.
Mem compare, right?
Yeah. Which is number 4, right? So it says that it will not meet this requirement somehow. By the way, the spec has more details. Before we started the work for this particular idea, it has more details how it saw it before it started the work for this step. If you check, let me say what to search
Spec
for.
is huge.
Yeah, I know. If you try to find pglz underscore find underscore match function name. One more time. One more. Yeah, here. This is idea 4. It was previous.
Go back.
Yeah. So it has. This is what it thought about starting the work, coding work and benchmarking work. Right. So now it thinks like we should remove this idea from the scope.
Yeah, I understand, because when we are like, there are 3-byte matches, and when we are matching by 4 bytes from the start, we are missing all 3-byte matches.
Exactly.
I think it's right. Yeah. And
But
I remember some guys who used this patch before. They complained that the patch affects how, like, it doesn't affect Postgres tests, but it was affecting Citus tests, because Citus was using a compressed column store.
C-store, yeah.
And they hard coded some result of compression, and it was different by 2 bytes. And I actually spent
That's
some time with them checking what's going on, and they just found that removing this line is
yes, this thing means that we need special tests here, because if Postgres test set has only like let's compress, let's decompress, and everything works, it won't verify that previous algorithm is compatible with new algorithm. We want to compress with, for example, with new implementation and decompress with old implementation to check compatibility, right? And current Postgres tests probably don't have it. What you just described is just basically half of this. Well, they had expected output, right? And verify that our new approach produces different output. But we don't need expected output. We just need some tests which would use both implementations, old and new, and compare.
I think
so the new compression, old decompression, and you must get back the same string.
Or just compress both and compare results.
Yeah.
Yeah. Use old,
actually, the upside of compressing both and comparing the results, and if we did that while the program was running, we could actually use those results to actually tell us the improvement in the thing. Now, we'd be slowing it down. We can't use it for CPU, but it would tell us any improvement. Well, it shouldn't. Everything should match. There should be no improvement in compression. So the only difference is speed. Yeah.
Well, this is a refined requirement. I need to refine spec now. But by the way, I forwarded you the list. Yeah. Interesting that Fibonacci stays in the list, and we have overall 7 ideas, which is not bad, right? Well, not of all of them are optimization, I think. Anyway.
And I think if we replace 4 by 3, we will get back to we can get this idea back to the list. but it might be net negative. Like when we are doing CMP with static length,
3.
it is using a specific instruction, assembler instruction to do this comparison. But when we will have 3 here, it will be hardware dependent. On some platforms, it can issue hardware operation codes to compare it, but on others, it will have to actually call memcmp, which is slow. So yeah, I think 3 bytes is not a good idea. Maybe not a good idea, but if we are dealing with like always AMD 64, like it's, I don't know, maybe it can check.
It's a good idea to check on various platforms as well. Yeah. So
Yeah, because in a CISC versus RISC too,
yeah.
right? A CISC is certainly going to have a 4-byte version of it, whereas a RISC may just do it byte by byte anyways. So all you're doing is calling one function to do a loop of 3.
Byte is just fine. I'm afraid that on some platforms it will do a call.
CISC,
It will
right?
actually jump somewhere and push something on the stack and do ridiculous stuff.
I'm laughing because I just imagined if my mother listened to us, CISC versus RISC, byte by byte. It's just funny. It just sounds funny, you know. Yeah.
Well, it is funny.
Byte by
I mean,
byte. Yeah.
I like bytes.
Yeah, it just sounds funny. Anyway, so I like what's happening here. Just some hardcore and AI mixed together. Let's think about the list of ideas which have potential. I can have new version of spec. Like it will be. By the way, if you scroll up, do I have revisions? No, I don't. This is wrong. Usually, I put I start versioning the spec, and I have revision history. What was changed to help reviews. So I'm going to have a version 2, maybe version 2.1, 2.2, and I will make this strict requirement that output must not change, right? We will develop tests for it. We will think about different various architectures. I'm not promising to touch Windows. Maybe we should, but actually, maybe why not? It's available in cloud. Maybe we should touch it as well. And then
I have a Windows machine actually. I'm using it to play with my son games.
Funny story. We chose Postgres because it was available in Windows. And then the first thing we ran into, this is version 12, is version 13 came out, and none of the extensions we were looking at were available for Windows. And we're just like, and then finally it was like, all right, how about we just split over and go to Linux for this? And in hindsight, yeah, I understand why Windows is the ugly stepchild it is. So.
Yeah. So this is probably the plan, right? So let's have version 2 of everything and just focus on ideas which don't change output. We also will adjust methodology of benchmarking, obviously lowercasing the t option, right? And what else? What is important? I'm trying to wrap it up because I have a different call very soon.
Okay.
But this work I enjoy. Like I basically like organize some team of AI agents, and now I see like there are some questions which like there is something to iterate on, which is great.
Thomas missed that. Okay, there is a lot of work that can and will be done that Postgres wouldn't get because people like you and people like me and many others have the energy for doing it at a different level.
Yeah, you imagine, it's like I need 2 weeks. I don't have 2 weeks, right?
Right, right. Or like you said before, your .c, your C coding skills aren't there.
Oh, they are
but
terrible.
You can write a spec to an agent like a madman. Like that's awesome, right? So, and for someone like me, where I'm getting too old. It's a young man's sport, but I can define specs, Okay. And
Right.
I can,
Right.
right. And I know what correct looks like. So I can still be more active. And so I think net it's positive.
If
Andrey
you if
smiling
you
because he's down.
if you have management skills, you developed a skill to recognize when engineer is bullshitting you. This is
That's
the core here. How to cross check and how to have some tests and like verification, and yeah, that's the
two
key.
two of my consulting clients literally have me on board to check the bullshit that the programmers are telling them.
Right. Right.
So right, we've all been there. Andrey, you're smiling too much. Are you
I
happy?
I wanted to of course, but I wanted to say that like when we are producing message to GSoC hackers, we need to give an easily reproducible benchmark. So we not just saying that we have run this benchmark, but we must say that you can run this benchmark
Yes.
and you will observe something like that.
Yes.
Like several easy commands that you can do
And
on
probably
your
drop
laptop
this
to observe it. Yes.
and probably adopt the whole story, because like this, it's not needed. We need just a final state, right?
Yeah. Just one good number, like 14% is great number actually.
Right.
So in several cases, we provide substantial improvement. And
Noticeable.
Yes.
Noticeable. I mean
don't see
substantial.
difference.
Yeah, well, 14% is substantial. Okay. I'm just, yeah.
I mean, banks know that 14% annually is a lot.
All right.
Yeah.
Not bad. If it was verified multiple times, but I think on just one platform. So we need to expand this and see the whole picture and so on. Yeah. Good.
All
Okay.
right.
I have something to work on. I will iterate. I will report you asynchronously. Let's revisit this later. I'm curious, like if there is potential here. I'm curious.
We certainly will send it to hackers. I'm not sure it will be mergeable to 19, but it will be mergeable at 20 for sure. I see this immense progress since 4.5 Sonnet, because it wasn't providing me a compilable version of C code after modification in this particular algorithm.
Good. Let's see what we will have in a week.
Awesome.
I will do some work here.
Thanks, guys.
Thank you so
Thanks,
much. I
everyone.
enjoyed a lot. See you soon. Bye bye.